The purpose of this video is to show you one region and then see how it's affected when we revolve around 4 different lines. So the first thing we're going to do is start off by drawing our region. We have this parabola, y equals x squared plus 1, so it's shifted up 1 unit. And we can kind of think of these as being 2 units each. And then we have a negative line and a positive y-intercept. And it's looking something like this. So the only thing we really care about is this region. We don't care about all the extra stuff. Now we're going to need to figure out what the limits of integration are. We're going to need to find what these intersection points are. So we have y equals x squared plus 1 and y equals negative x plus 3. So we can solve that by substitution. X squared plus 1 equals negative x plus 3. Move everything to one side. Factor. So we get x equals negative 2 and 1. And that pretty much agrees with what our picture is here. Now depending on if we need the x numbers or the y numbers we can just plug it into one of these two equations. So this would end up being 5 and this would end up being 2. Now we need to determine what kind of rectangle. Can we have both types of rectangles here? We're either going to have a vertical or we have the horizontal. Remember, we want to slide it up and down our region. Let me start with a horizontal on this one. I'm just going to draw a bunch of them instead of sliding it mentally to show you. So if I'm starting up here and I'm coming down, these first couple all the way down to this point are computed the exact same way. Right minus left is the line minus a curve. But once I get below this point, then it's both ends of the rectangle are on the parabola. That's not something we want to deal with. It's possible most of the time, and probably all the time, but we're not going to deal with that. Sometimes the computation can get really ugly. So now that means what we're probably going to do is a vertical rectangle, and let's draw this again. Except this time when I draw it, I'm just going to draw the part I want. And I'm going to draw my axis of rotation. So I'm going to start above and I'm going to rotate it around. I'm going to copy my region, and so this is about 3 away, so something like this. Now are those perfect copies of each other? No, but we don't need to worry about that. We want the basics down. So let me draw my vertical rectangle and let's slide this up and down. If I drew one over here, if I drew one down here, is it always the same? The top curve, in this case the line, and the minus the bottom curve for the length of that rectangle? Yes. And that's what we want to do. Now we're going to take this rectangle, actually you got to label this delta x. Let's copy it into the other region in the same relative position. And now let's connect them. And you can see the washer. Now remember, what we're going to do with this is we need to find the area of this washer, and it's this region here, and then we multiply that by a thickness of delta x and we get a volume. And then when we do that, we're going to sum them all up in the entire region. After we sum them up, we'll find the limit as the thickness goes to 0, and that's going to give us our integral. Until we get to there, let's go through the steps. We need to find our radius. So we'll have a little radius, an inner radius, and an outer radius. Now, this point right here, in fact, any point on the curve is going to be called an x comma y. And any point on this one will be x comma y. It's a different y value, but we have xy represents any point on the curve. So when I'm looking at this inner radius, this is a vertical distance. What numbers describe vertical distances? Y. So it's going to be the top y value minus the bottom y value. So we'll have y minus negative 1, and this gives us y plus 1. Now, what is our integral going to be in terms of? The thickness is delta x, and that tells us everything is in terms of x. So we can't just leave this y. On the inner curve, that is going to, the one below here, that will be the parabola. So it's x squared plus 1, and then we're going to add 1, so we get an inner radius of x squared plus 2 for all rectangles that we have and we slide when we slide it in the region. The capital R is going to be the exact same thing. It's going to be y minus negative 1, except what's the y value this time? The y value this time will be negative x plus 3 plus 1, so we'll get negative x plus 4. Move it up so we can set this integral now. Now, when we're sliding it through, again, we're dealing with x numbers. What is the smallest x value? The smallest x value is over here, and the biggest x value is there. And we've computed those numbers right here, negative 2 and 1. So the area of this face, it's going to be a circle. We have pi r squared, and we can just factor out that pi, and we have negative 2 to 1. Capital R squared, the outer radius squared, negative x plus 4, quantity squared, minus the inner radius squared, which would be x squared plus 2, quantity squared. Then multiply that by dx. Now we need to go through the algebra to simplify this, and we'll have the integral from negative 2 to 1, leave that pi out, and we have x squared minus 8x plus 16 minus the quantity of, you have to be very careful with that negative in the parentheses. You need to make sure you have that parentheses or distribute it correctly immediately. Now combine all the like terms, and we'll have negative x to the 4th minus 3x squared minus 8x plus 12. Now we can find the antiderivative of that, and that will be negative 1/5 x to the 5 minus x cubed minus 4x squared plus 12x, and then we'll evaluate that from negative 2 to 1. Again, check to find the derivative of each one. Yep, they all work. Now plug in, so we'll have negative 1/5 minus 1 minus 4 plus 12 when we plug in 1 minus, again, make sure that parentheses there. So this time we have a negative 2 to the 5th would be negative 32, so this will give us a positive 32 plus 8 minus 16 minus 24. And then we have all of that times the pi. So in this part we have 7 minus 1/5, and over here we're going to have negative 32, so that'll be a positive 32 when we distribute. And then we have minus 6 and 2/5. So we have 39 minus 6 will be 33, and this is also going to be a negative 2/5, so 33 minus 3/5 would be 32 and 2/5. Make sure I have my pi there. You could also write it as 162 over 5 times pi. And that's it. Let's take a look at the next one. What happens when we rotate around a different line? So we have the same basic setup, except now when we draw this, let's sketch the region again. Again, I just want the part that I need. And we had already figured out that this number here was 5, and so 6 is going to be something above. We're starting below. We're going to round or revolve around it, and we're going to copy this now. Now sometimes copying this can be a little bit hard for some, so we're going to have it something above, and it was going down, and so now it's going to be going up there, and once we can get there, you can sketch that parabola part to it. So now we have our region, and we're going to draw our vertical rectangle. We already know it's going to be vertical because we've determined back here at the beginning we're not going to do a horizontal in this problem. Copy that region copy that rectangle in the new region, and then connect the dots. So you can see again we have another washer. We need to compute the inner radius here and the outer radius. So how do we go about doing this? Now, label there, we have little r. Again, little r is going to be the y values. Okay, so it's going to be this y value minus this y value. Well, what is the top one? That's at 6. So it's going to be 6 minus that y, and that is a line, so 6 minus negative x plus 3, which we get 3 plus x, or we can say x plus 3. And then we have the capital R, and that's going to be computed the same way, except this time it'll be the 6 minus y, and the y is x squared plus 1. So that'll give us 5 minus x squared. Now let's go ahead and set this up. Again, we know what our limits of integration are, so it's going to be pi, and we're going from -2 to 1. The outer radius, 5 minus x squared, quantity squared, minus the inner radius, x plus 3, quantity squared, dx. And the rest is very similar to what we just did. Instead of going through all of it, I'll let you do it, but I'll give you what the results are going to be. This will give us x squared minus 11, or x to the fourth minus 11x squared minus 6x plus 16 dx. And you can find your antiderivative, and then when you finish it, your answer for this problem will be 153 pi over 5, or in other words, 30 3/5 times pi.